Alright, in this video we're going to talk about what a conjugate is. To me, conjugates in math are some of the coolest things ever. So basically what it is, when you have a binomial that has an irrational number in it, so let's say we had 4 minus the square root of 3, its conjugate would be 4 plus the square root of 3. Or maybe if we had 2 plus the square root of 3. Its conjugate would be 2 minus the square root of 3. So you just change that sign in the middle of it. Let's say, I'm just going to throw one over here. Let's say we had negative 5 minus the square root of 7, for instance. That conjugate would be negative 5 plus the square root of 7. So the only sign that changes is that middle one. And that's what makes a conjugate. So what's kind of cool about a conjugate is, let's take a look at the number 2 plus the square root of 3. If you plugged that into a calculator or wanted to find its decimal representation, 2 plus the square root of 3 is approximately 3.732 ... That number goes on for infinity. It's irrational. And its conjugate is also irrational. So 2 minus the square root of 3 is about equal to 0.2679 ... So those are the two irrational numbers, 2 plus the square root of 3 and 2 minus the square root of 3. Imagine multiplying 3.732 ... times times 0.2679 ... And imagine having to multiply that and think, well, what are we going to get? Well, I think what we're going to get is 1 when you multiply those two irrational numbers. To me, that is beautiful. And so let's go ahead and do it. So let's take the actual numbers, the conjugates, and multiply them together. So 2 plus the square root of 3 times 2 minus the square root of 3. So if you do that, 2 plus the square root of 3 times 2 minus the square root of 3, you're going to multiply those much like you multiply any binomial. You could use FOIL, sometimes that's called, I like to call it distribution. We're going to take this 2 and distribute it through the binomial, and then we're going to take the square root of 3 and distribute it through the binomial. So if you don't have a lot of practice with this, just remember you have to multiply numbers and numbers, roots and roots. Everything else you kind of keep separate. So 2 times 2 is 4. That's that first one. And then you take 2 times negative square root 3. Well, that would be negative 2 root 3. And then the middle one, you take root 3 times root 2 right here and right here. Or sorry, times 2. So that would be plus 2 root 3. And then you take root 3 times negative root 3, which would be negative root 9. 3 times 3 is 9. Well, notice here in the middle, you've got negative 2 root 3 plus 2 root 3. Well, that's 0. So now we're left with 4 minus the root of 9. Well, the root of 9, you know, is 3. So we really have 4 minus 3, which is 1. And indeed, we've multiplied two irrational numbers like this and this, 3.732 ... and 0.2679 forever, multiplied those together and got the number 1. It's fascinating. I'm easily impressed, I guess. But so the conjugate, hopefully that looks familiar to you. You've been working with this. By the time you get to conjugate in mathematics, you're usually in algebra 2. Sometimes you see it in algebra 1, depending on the teacher you had or the course you had. But it comes from a minus b times a plus b. You've seen that. That is the difference of squares, a squared minus b squared. And so it should be starting to look familiar to you as something you've seen before. And if you multiply those together, you get a squared minus b squared. So let's talk about the next part. The next part is how it is used. Let's say we took 5 divided by that number 2 plus the square root of 3. That would be a difficult thing to do if you had to do it by hand. I mean, obviously everybody has computers and calculators that do this for you, but that hasn't always been the case throughout human history. And so, this would have been back in the day an impossible thing to get precisely right, because you basically would be saying take 5 and divide that by 3.732 dot dot dot. Well, it's tough to divide by an irrational, because if you know your algorithm for this, you move this over so many places and you move this over so many places. Well, how many places do you move? You can't move forever. It's impossible to do. So it'd be much simpler if you could rationalize this number. So if we rationalize this 2 plus root 3, we know that if we take it times that conjugate, it will become a 1. So that's exactly what we do. We take it times its conjugate, and whatever you do to the bottom, do to the top, so that you have so that this number here on the right is a 1. 2 minus root 3 divided by 2 minus root 3 is simply 1. So I've taken it times a really cool looking 1. And so what we have then is, if you use distribution, 10 minus 5 root 3 on the top, distributing the 5 through. And on the bottom, again, we've already done that, but it's 4 plus 2 root 3 minus 2 root 3 minus root 9. And so that simplifies to 10 minus 5 root 3 all over 1, which is 10 minus 5 root 3. So we've divided 5 by 2 plus root 3, and we end up with another irrational number of 10 minus 5 root 3. And that's simplified. So that's, whenever you have a radical in the bottom, we like to rationalize it. And that's where this is used. So it even works with complex numbers. Complex numbers, if you, maybe you've had them, maybe you haven't. That's why I kind of saved it to the end of the video, because by here most people are done watching me. So a complex number is when you have a real number with an imaginary number. So 2 plus 5i. So that's a complex number. If you take 2 plus 5i and multiply it by its conjugate, which would be 2 minus 5i, you end up with a real number. It's no longer imaginary. So let's do that quick. Again, 2 times 2 is 4. 2 times negative 5i is negative 10i. 5i plus 2i is positive 10i. And 5i times negative 5i is negative 25i squared. Well, the 10i's cancel out. So you're left with 4. This here in the middle is 0 minus 25i squared. We also know, if you've studied imaginary numbers at all, I squared is the number negative 1. So this is 4 minus 25 times negative 1, or 4 plus 25. 4 plus 25 is 29. So that's, again, I think that is cool. We have taken two complex numbers, 2 plus 5i times 2 minus 5i, and ended up with a real number of 29. I forgot what the number was again. I don't know. That's just the coolest thing ever. And so if you have a complex number in the denominator, again, and this is where it's used, the conjugate is used. If you had, say, 2 minus I over 3 minus 4I, something like that. Again, you're going to go ahead and multiply that by its conjugate to rationalize that denominator so that you could divide. So that would be 3 plus 4I, top and bottom. That's your conjugate. And so on the top, you've got to distribute through the top, and that's 2 times 3 is 6. 2 times 4I is 8I. Negative I times 3 is negative 3I. Negative I times 4I is negative 4I squared. And on the bottom, you do the same thing. You would have 9 plus 12I minus 12I minus 16I squared. And what's cool then is, again, on the bottom, this 12I and negative 12I are 0. And so you'd have, and this becomes, because I squared is negative 1, a positive 16. So 9 plus 16, so on the bottom we have a 25, because that's 9 plus 16. On the top, 6 and negative 4I squared would be 6 plus 4, which would be 10. And 8 minus 3I is plus 5I. You could, so there you have it. You could simplify that a little further, and usually we always like to leave complex numbers in the form a plus bi, where your real number is the a part, your imaginary number is the b part. So you just split this up. 10 25ths plus 5i over 25, and then simplify it from there. 10 25ths is, you can take a 5 out, so that would be 2/5. 5i over 25 would be I over 5, or 1/5 I. So 2/5 plus 1/5 I. And so that's how you'd simplify if you divide by a complex number. So I hope this helps. That's what a conjugate is and how it's used. And hopefully somebody gets some value out of it. See you next time.